Hey, hello, good morning, guys. This is Coding with Gautam, and today we will be continuing with our YOLO software detection. So, yesterday we stopped when I was explaining blobs, and today we will talk about the for loops, and we're going to be talking about the for loop layers in initializing detection, and I will be processing layer outputs. So first, let me just explain the code from the blob, just a brief review. So this is the net set input blob. So that basically creates a blob as the input for the YOLO model. This model will process the input to generate object detections. Then getting output layer names, this line retrieves the names of the output layers from the YOLO model. These layers will contain device information. The forward pass, so basically this line performs a forward pass through the YOLO model. During this pass, the model processes the input blob and generates the detections based on the trained weights and configuration. These results are then stored in a list named layer outputs. Then initializing the detection data, these lines initialize the empty list to store the following information for each detected object. The boxes this is the list that will hold the bounding box coordinates x, y, width, and height for each detected object. Confidences, this will store the confidence scores associated with each detection. The confidence score basically tells you that how much, like at what percent the model thinks that the object belongs to the class, the predicted class. Class IDs, this will contain the class IDs given from the YOLO file, the configuration file, and the class file. And these indices will refer to class names loaded earlier. Okay, so now let's cover this. This is the main crux of our code. So, processing detections. Here we can see that first we extract class and confidence. So first we just loop over each of the layer outputs for every layer in the neural network. Then we loop over each detection that is found. So then scores equals detection 5 colon. This line extracts the class scores from the current detection. These scores represent the model confidence for each class in the dataset. Models such as confidence, such as person, car, bicycle, and also just quick overview that the detection format may vary depending on the YOLO version. We're skipping past the first 5 elements, that's why we're using 5, as they might contain bounding box location data specific to the YOLO architecture. Then we filter detections by confidence. So if the confidence is greater than the confidence threshold, I'm just talking about this real quick. Class ID is the np.argmask. This line basically finds the index of the class with the highest scores. Confidence is basically the scores. So we go through scores and we index through class ID. We're basically getting all the confidence scores. Then we just make sure if the confidence is higher than the threshold, we don't want too many detections. And then we filter by confidence. Then we scale bounding boxes. So this line box detection 0 to 4 times numpy array with height. This line retrieves the bounding box coordinates x, y, width, and height from the first 4 elements of detection, assuming YOLO stores the formats this way. It then scales these coordinates back to the original frame size, width, and height using element-wise multiplication by a numpy array. We need to do this because YOLO model might operate on different input size from training. We're just basically trying to normalize all the data. Then we're extracting the corners, center x, center y, width, and height. And this line is converted into bounding box coordinates, floating from numbers to integers using as type integer. It also unpacks the values into separate variables for clarity: center x, center y, width, and height. Then we calculate the top left corner. Basically, we use the center x and y coordinates to derive the top left corner. So we do the center x minus the width divided by 2. So if we're at the center, assume that this is a rectangle. If we're at the center here, if we minus by the width divided by 2, and next then we do y divided by 2, we have the top left corner. Then yeah, just simple. Then storing the detection data, boxes append xy int width int height. Basically, this line calculated the top left corner coordinates along with the width height converted to integers to the boxes in the list. This list stores bounding box information for each list detection. Then confidence.append float confidence. This appends the confidence score as a floating number to the confidences list. And then class IDs append class ID. This line appends the class ID to the class IDs list. This ID refers to the most likely class for current detection based on YOLO model prediction. Now, we will be talking about non-maximum suppression, which is this line right here. This line is basically the crux of our code, and this is non-maximum suppression. So this code snippet basically uses OpenCV's function to perform non-maximum suppression. NMS is a technique commonly used in object detection. So basically it addresses the overlapping bounding boxes. So the breakdown of the code, first we take the boxes. This is the list of bounding boxes, where bounding box is a list containing 4 elements: x minimum, x min, y min, width and height. Then these coordinates represent the top left corner and the dimension of the bounding box, like we've defined earlier. Then confidences, this is the list storing the confidence of the object we detected being in the class defined. Then confidence threshold, this is the minimum confidence score for a bounding box to be considered valid. Any box with a confidence score below the threshold will be discarded before NMS. NMS threshold, this is the non-maximum suppression threshold. It determines how much overlap is allowed between bounding boxes before one with the lower confidence score is discarded. Then the sorting, the function first sorts the boxes and confidence lists together based on the confidence scores in descending order. This ensures that the boxes higher confidence, more likely to be correct, than processed first. Then we loop. This function iterates through the sorted confidences list. For each confidence score, it retrieves the corresponding bounding box index from the sorted boxes list. It checks the overlap intersection over union and IOU between the current bounding box and subsequent bounding boxes. So it just checks for each confidence score and it iterates to the sorted confidence list, checking for the boxes. Overlap check, IOU is a metric used to calculate the overall overlap between the two bounding boxes. It is calculated by the area of intersection between the boxes divided by the area of their union. So it basically detects that whether these two are overlapping and by how much. Then if the IOU between the current bounding box and any other subsequent box exceeds the threshold, then the subsequent box is marked for suppression. And then we suppress it. This, after iterating through all boxes, the function creates a new list called IDXS. This function, and then that list, not function, contains indices of the bounding boxes that survived the NMS. These are boxes with the highest confidence score or those with the minimal overlap. Then IDXS, this list contains the indices of the bounding boxes remain after you apply NMS. The non-suppressed boxes will be used for further processing. So this is NMS. So just to sum up, NMS is what we use to make sure we're not using too many overlap boxes and that things that should be boxed are boxed. We did this by taking the top left corner of the boxes, defining all the boxes, looping through the confidence and checking the confidence threshold, and then making sure that overlap is minimal and that if there is lots of overlap using the IOU metric, we suppress it. So any questions, hit me in the comments and I'll do my best to answer. Thank you guys for watching. Don't forget to share and subscribe. This is Coding with Gautam and I'll see you next time. Have a good day.